In the last video that we did, we found the derivative of a function. And that is, we found the slope of a curve, and it was a function, and that function had variables in it because the slope changes throughout the function. Now, there's a shortcut that exists, and that shortcut is called the power rule, and it's only for those variables that are just plain x. No, not a multiplication of or quotient of x, is just a plain x. So it's called the power rule. Let's look at the objective. Let's state the power rule for differentiation. Find the derivative of a variable with a positive whole number. So I'm going to notice here that we're going to start off with the power rule. Okay, you got to state it. Then we're going to start off with positive whole numbers. Then we're going to change them to negative whole numbers. Then we're going to go to rational exponents. That means that fractions, right? And then we're going to say those that are under a radical. And then if they're in the denominator, and then if they're in the denominator but also under the radical. So we're going to be building up. All right, so let's go ahead and state that the power rule. But before we begin, I know in the last video we talked about the notations. What is going to be the notation when we find the derivative? Well, once you find the derivative, if you see this notation, that means that that's the slope of the original function. That's the slope of the original function. That's the slope of the original function. Or some people might use, this is very popular in physics. And here, if you notice, the y right here is really f of x. But they don't put it on top, they put it to the side. So it's d over dx. So d over dx, and then they'll put in the function here. So this is a very popular notation, okay? So let's go ahead and state that the power rule, all right? But before we begin, let's see if you could figure out the power rule shortcut, all right? So here we go. I'm going to give you a function. The function is x cubed plus 2x to the fifth, and the derivative is 3x squared plus 10x to the fourth. Okay. Let me give you the next one. The next one is 4x to the 6th plus 8x squared, and we're going to end up with 24x to the 5th plus 16x to the 1 power. Some of you might say, oh, I think I have it. Look at the third example. The third one says 7x to the 5th plus 17. And this is going to give us negative 35x to the negative 6. Some of you might get thrown out. Well, what happened to the 17? All right. The next example, we have 5x to the negative 2 minus 8x. That's going to give us negative 10x to the negative third power minus 8. And finally, the last example is x to the 2/3 plus x to the negative 2/5. And that's going to give us 2/3 x to the negative 1/3 minus 2/5 x to the negative 7/5. Do you see the pattern? If you don't see the pattern, I recommend that you stop the video right now and try to see if you can figure out the pattern. If you figure it out, it's a lot better if you figure it out on your own rather than I just tell you. Okay? So here we go. What is the power rule? For those of you that didn't see it, if I have x to the n, I'm going to take the power and put it in the coefficient. So now it's going to be n times x. And then what I'm going to do is I'm going to subtract 1 from my power. So I'm going to have n times x to the n minus 1. And that is the power rule. And that's all we're going to be doing in this video. All right? So let's start off. The very first one is going to be just positive whole numbers. This is everybody's favorite. Everybody's like, I can do this, or this is easy. So remember, I'm going to take the 4 and put it in the front, but there's already a 4 there. So 4 times 4 is 16x to the 3rd. Plus, now I'm going to take the 7, put it in the front with 11. So now I'm going to have 77x to the 6. I subtract 1 from each power. Let's try another one. 4 times 10 is 40. X, subtract 1 from my power. Now I'm going to have 3 minus 6x. 3 minus 1 is now going to be 2. And this is going to be my derivative. This is going to be my derivative. And I'm going to be using different notation so you can get used to it. Okay? Now, we're going into something new now. What happens if my powers are negative? This, believe it or not, students have some difficulty. Not everybody, but a few. So right here, I'm going to take the negative 5 multiplied times negative 3. That's going to give me 15. So I'm going to say f prime of x is going to be 15x. And here's the mistake a lot of students will make. They're going to go with negative 4. But in reality, it's really negative 6. Because negative 5 minus 1 is negative 6. And then the next one is going to, we're going to multiply negative 6 times 8. That's going to give me negative 48. X to the negative 7. So this is my derivative. This will help me find the slope of my function anywhere. All right, let's try another one. So on the next one, we have dy dx is going to equal, let's multiply negative 2 times 5. That's going to give me negative 10 x to the negative 3. The next, when I multiply negative 1 times minus 2, that's going to give me plus 2 x to the negative 2. And this is the derivative. So what we did was, we did the powers were all positive, whole numbers. Now they were negative. So now the next one is, I'm going to give you the function in the denominator. And some of you can say, sir, I have no idea how to do this problem. Well, you have to apply a property from algebra. And all I'm going to do is I'm going to shove this guy up to the top. I'm going to take this guy and I'm going to shove this guy up to the top. When I shove him, I have to change the sign on my exponent. So that's going to become negative 2. And then the other one's going to become x. There's a 1, so when I shove it up, it becomes a minus 1. Now, I have not done the calculus part. I only did algebra. So now we're about to take the derivative of that. And the derivative of this is going to be, okay, so let me go ahead and put here, y prime is going to equal to negative 6x to the negative 3. Here I'm going to multiply negative 1 times 1. That's going to be minus 1x to the negative 2nd. Now, if you want to, you can always rearrange it back into this notation. So my answer is going to be negative 6 over x cubed. And then it's going to be minus 1 over x squared. And this is my derivative. All right, let's try another one. Let's try the next one. What we have is we have this one. Oh, look what happens. What happens when I shove that guy up to the top? I'm going to end up with 4x to the positive 5 minus 1x to the negative 6. Now, I have not done the calculus. So my derivative is going to be 20x to the 4th plus 6x to the negative 7. And that is the answer, or if you want to rewrite it, we're going to say that the answer is 20x to the 4th plus 6 over x to the 7. And this is my answer. All right. Let's continue. Now, this one here, what we're going to do is we're going to do the exact same thing. Now, students hate this. And they hate it because they see fractions, but they don't realize that it's the same thing. So my derivative is going to be 3 times 5 over 4 x to the 5 over 4 minus 1 minus 3 times 7 over 11 x to the 7 over 11 minus 1. Now what I do is I rewrite and I put it as minus 1, but this is going to be 4 over 4 because I'm trying to have the same denominator. And over here I want to put 11 over 11 so that they can have the same denominator. So now when I multiply my coefficient to my power, I'm actually going to end up with 15 over 4 x, and here I'm going to say 5 fourths minus 4 fourths is going to be 1/4. And on the second term here, I'm going to multiply 3 times 7. That's going to give me 21 over 11. X to the 7 11ths minus 11 11ths is going to be negative 4 over 11. And this is my answer right here. This is my derivative for this function. All right, let's try the next one. I am going to have my derivative, which is y prime, is going to be 3 times 4 sevenths x to the 4/7 minus 1 minus 2 times 3/2 x to the 3/2 minus 1. And what did I do? I went ahead and I changed this guy to 7/7, and over here I'm going to change it to 2/2 so that they can have the same denominator. So here I'm going to end up with 12/7 x to the 4/7 minus 7/7 is minus 3/7 minus 3, because 2 times 3 is 6, 6 divided by 2 is 3, x to the 3/2 minus 2/2 is 1/2. And this is my slope. This will help me find the slope at any point for my original function. Now, the next type of example is when we have the equation in radical form. And what you need to know in order for you to do this one, you have to remember this. This here is called the root. This guy is called the root. And this guy is called the power. So when you rewrite it, where do you find roots on a tree? In the bottom. You're going to put the A on the bottom and the B on top. So you need to understand that this is going to be written as this. So what we're going to do is we're going to rewrite these functions first before we find the derivative. So the first one's going to become 5x to the 2/3 plus 3x to the 11/5. So I rewrote it. I have not taken the derivative, I just rewrote it. So now we're going to find the derivative. So we're going to say 5 times 2/3 x to the 2/3 minus 3/3 plus 3 times 11/5 x to the 11/5 minus 5/5. And that is going to give me 10/3 x to the negative 1/3, and then plus 33/5 x to the 11/5 minus 5/5 is going to give me 6/5. And this here is my derivative. All right, let's try one more. That's going to give me, let me change the color here, negative 8 x to the 7/5 minus 7 x to the 13/10. So when I take the derivative, I'm going to get negative 56/5 x. And now what I do is I teach my students that it's always going to be the denominator. So I'm always going to go 7 minus 5. 7 minus 5 is 2/5 here. Oops, let me change this back to black. 2/5. And then here I'm going to multiply 13 times 7. That's going to give me 91/10. And here I'm going to go 13 minus 10. That's 3/10. And that is my answer. That's my slope. Okay? Now here comes a combination of everything that we've done. Okay? Oops, not yet. Now I'm including some negative powers to those rational roots. So I'm just going to do the exact same thing. I'm going to multiply that, and my slope, my slope is going to equal to 14/5 x. Now let's use that shortcut. 7 minus 5 is negative 12/5 minus 60/11. X to the negative 6 minus 11 is going to be negative 17/11. And this is my answer. And I'm done. All right, the next one. Now I'm going to get negative 12/5. Negative 2 minus 5 is negative 7/5. And here, when I multiply negative 1/8 times 2, is negative 2 is going to become plus 2/8, which is really 1/4. X, negative 1 minus 8 is negative 9/8. And this is going to be my derivative. All right? And now comes the hardest one. This one though, you see what this problem does is it gives you the radical, gives you the denominator, and then you also have to rewrite it. So on this one, I'm just going to rewrite it as 3 over x to the 1/2 plus 1 over x to the 3/7. And now I'm going to shove them up, and I'm going to have 3x to the negative 1/2, and then plus 1x to the negative 3/7. And now I'm about to take the derivative. The derivative of that is going to be negative 3/2 x minus negative 1 minus 2 is going to be negative 3/2 minus 3/7. Negative 3 minus, negative 3 minus 7 is going to give me negative 10/7. And this is my answer for the derivative. Okay, the last one, let's rewrite it. And some of you will be able to skip this step. So 4, but I won't do that. 4 over x to the 7/5 minus 3 over 7 x to the 5/4. All right, let's shove the x's up. 4x to the negative 7/5 minus 3/7 x to the negative 5/4. So now let's take the derivative. Dy dx is going to equal to negative 28 over 5 x to the negative 12 over 5 plus, and now why is it plus? Because you have a minus and a negative. That's going to give me 15 over 28 x to the negative 5 minus 4 is negative 9/4. And this is going to be my solution. And that concludes the derivative using the power rule.